Today I'm speaking, as Mark already said, about custom lens solutions and how they can boost precision in high-end applications. Before starting the talk, let me briefly introduce myself and the company Schneider Kreuznach that I'm working for. To myself, I'm with Schneider Kreuznach for 14 years, so after studying physical technologies. Started my career in engineering and later moved to sales, now globally responsible for industrial sales in Schneider Kreuznach. About the company, we were founded in 1913. German-based company in Bad Kreuznach, about 2.5 hours from here. Still family-owned business, and we have offices worldwide: Los Angeles, New York, Shenzhen, Hong Kong, and Singapore. We are proud to say we are one of the few optics company with a fully vertically integrated manufacturing. So we do the development in Germany when it comes to optical design, to lenses. We do the mechanical design. And we have full capability of manufacturing from component level to system level. We do all the optical coatings, assembly, and of course quality inspection is a big topic and important for us to come up with high-end solutions. Well, why am I speaking about custom optics? There's so many optics down in the market. Hundreds of lenses you can see on this show, many exhibitors showing optics, standard commercial off-the-shelf items. But still there is a need for custom optics. But why is this? This is basically what I'm talking about today. And one of the main aspects, the 4 reasons that we find in the market for custom optics, is to match your application with a custom optics, to reduce costs in the application, to boost performance, and in many cases we have quite unique optical requirements that make it necessary to come up with a custom solution instead of a commercial off-the-shelf item. This presentation will show you a couple examples for these 4 reasons to go for the custom optics. First example is a small modification of a standard product that we are selling. It's a 2/3 inch C-mount lens. You can see it on the left-hand side here. And this is a catalog product that you can buy from Schneider. However, in this application that you will see next, we had very limited space, very harsh environmental restrictions, and also some weight requirements, because this lens actually went to space. This is a James Webb Space Telescope, and this is the detaching of the telescope from the rocket. And the lens you saw one slide earlier basically took these images. So a standard product, slight modifications, it becomes a custom item, but it's necessary to really match the application. Another example we are proud of and we are happy to speak about, because many projects we are not allowed to speak about due to NDA restrictions, is a project we did for the US Postal Service. We delivered about 20,000 of these lenses, and basically every letter in the US that is being sorted is being watched with these lenses. So they do the optical character recognition with this lens, very high-speed application, and in this case, by requiring 20,000 pieces of a lens, it's been a lot cheaper to go with a custom optic compared to a standard product, because this product is matched to the application. It's basically stripped down of all the other performance parameters not needed in this application. Sure, there is some upfront cost for the development, but in the end this project probably saved the US Postal Service quite a couple millions in US dollars instead of going with a standard product. Another example on our end, boosting performance. This is for a customer with a very specific working distance requirement, 950 millimeters, and a very specific illumination with 450 nanometers. On the left-hand side, you can see the MTF versus field plot of this standard lens. However, we did some minor modifications, some tweaks to the optics, not going with a lot of costs, but still boosting performance significantly, which you can see on the right-hand side here. So MTF is improved by modifying a standard product and optimizing this product to the application. Unique requirements come quite often. This goes mostly to electronics and display inspection, where we are faced with high magnification lenses. In this case, one of our commercial off-the-shelf products, a 3.5x lens, to allow modifying and monitoring submicron defects on a display. However, this lens is very specific. It needs to be used at a specific magnification, because when you slightly change magnification, which you can see on the right-hand side, performance is dropping quite significantly. So you will find a lot of commercial off-the-shelf products in this market. Still, modifications are required to come up with high performance and allowing for defect detection. Another great example of very unique requirements is set up with a project done with Facebook back in the days. They were going for image capturing for their Oculus. They wanted a 5 degrees of freedom image captured. So basically they are not only capturing the image, but they are really taking a 3D image of the area they are monitoring. What we did here is the development of 180-degree fisheye lens with a very high resolution, very low distortion, and basically capable of measuring stereoscopic and 3D measurement. Another important requirement is the thermal robustness and also the performance regarding stray light, because this device, basically this size, is used in many applications where we have lights like on stage here that can enter the lenses. This started off with a commercial off-the-shelf product, but found out it's not the performance they require, and this lens really helped them achieving the performance needed to come up with images that can be used in a couple of years with even higher resolution devices for the Oculus. More examples on unique requirements. Later in this session we will hear a little bit from Midopt about filters. Schneider also does filters quite a lot. We have our own coating capabilities for filters. And usually with the wide-angle lenses we have a problem when we place the filter in front of the lens. Because of the steep angles the light is going through the filter, we have different effects going on. This could be a blue shift or could be changing the optical density. And this is why in this example we decided to place the filter inside the lens. This is a big advantage when you have a company doing the lenses and the filters. So we are able to basically integrate the filter in the middle of this lens, allowing for very shallow angles of incidence for the light hitting the filter. And this helps us, as you can see on this slide, with a traditionally coated filter. You can see on the left-hand side we have an effect which we call blue shift when there is a steep angle of incidence. When we place the filter in front of the lens, we can see a maximum angle of incidence of 47.8 degrees, coming up with a blue shift of up to 93 nanometers. So when you're looking into a specific wavelength, this filter basically doesn't help because it's performing differently over the field of view of the lens. Compared on the right-hand side, when the filter is placed inside the lens, we only have a maximum angle of incidence of 8.5 degrees and a maximum blue shift of 1 nanometer. So that's a big help in terms of positioning the filter and in terms of improving performance in the application. Well, obviously you can say, well, we can go for a color glass filter instead of an interference filter, which would also solve the problem. But still, when you hit that color glass filter, which is basically absorbing light, on the one hand side it's heating up. So if you have a high power application, it won't work. On the other hand side, when you hit that filter on a steep angle of incidence, the optical density will change with this filter. So again, in many applications it's not possible, and the best solution is to place a filter in a position with a very small angle of incidence. Going on with a couple more real custom lenses, because what we saw so far is mostly modifications of existing products. In many applications, customers approach us with very unique requirements. And this really depends on developing a new lens, developing a full new product that allows to match those requirements. This example is together with the Allen Institute, an institute in the US founded by Paul Allen. And they are currently investigating neurosciences and really trying their best to help us understand what's going on in the human brain. Still, they need more resolution to really capture neurons in the brain. Right now, they are doing a lot of experiments with mice brain, and we're currently developing a lens for them with a 10x magnification, a numerical aperture of 0.5, so very high open aperture, and still a diffraction limited lens. So why is this required? Well, more resolution, more resolving power on the object side. Very unique requirement is a very large sensor with 67mm sensor diagonal. So you won't find a microscope lens with that much of a sensor size resolving power. So we go for a custom lens. The wavelength range is basically a little bit extended of the visible range from 435 nanometers to 780 nanometers. And it's a 4-color channel camera setup that we have behind the lens. So very unique system, very high requirements, very demanding requirements, and well, basically up-to-date research in neurosciences that we help with, hopefully helping us within the next 10 years to really understand more of what's going on in the human brain. Long story short, very unique application, very unique requirements. What we do is sit together with the engineers from the Allen Institute and really look into their requirements and come up from basically a blank piece of paper to a complete new lens that is being developed and produced. Well, another example, I already spoke earlier a little bit about display inspection and how display inspection has very specific requirements. Again, they are faced with high magnifications, sub-micrometer defects that need to be detected on the electronics behind each pixel. So what we are really doing here is detecting defects down to 0.3 micrometers. It's not really resolving those defects, but it's finding the position of these defects in this application. Again, we go for diffraction limited lenses, very specific magnifications required depending on which display is being inspected. And again, large line scan sensors that are being used in the application. So here it's necessary to go with the approach of custom optics. While it's cost intense to develop those lenses, it is required to really capture those defects and to get best performance matching the system level, matching the illumination, also the camera, that all need to be considered when developing a lens. And as Mark already said, optics is often forgotten, but still it's necessary. I mean, I always tell people a lens cannot capture an image, but without a lens you cannot capture an image. And many people really think too late about the lens. What we see a lot is people starting with a sensor and later thinking about the lens. And what we really want people to understand is when you start with the lens, you have a lot more options. By selecting a sensor first and choosing the optics last, you can run up in quite a few problems and not finding a commercial off-the-shelf product. Considering all the optical components together at the first stage can be really helpful to come up with best solutions for your application. So that's it basically for today's presentation. Come and visit us down in Hall 10, booth C26. We have a lot more applications showing on our booth. Our engineers are down there to help you understand more about what we do in terms of specific custom optics and also commercial off-the-shelf items. And yeah, feel free to visit our booth. Thank you for your attention.
Thank you, Magnus. That's really enlightening. So I've got a couple of questions. Firstly, has anyone from the floor got any questions for Magnus? No? So one of the things I see of some of those requirements were very specific.
Yes.
Does the customer know what those requirements are? Because quite often, you know, if you've got someone that really doesn't understand optics, they're putting their standard lens on, not getting the result they want. How do they know that that's what they need to move? That filter was incredible, moving the filter to the center of the lens, how it completely transformed the response.
Yeah, well, it's basically we see like two types of customers painting this black and white. So there's the one customer really understanding optics and coming up with really well specification for a lens. Sure, this is sort of the easier job, so to say, when the customer really knows what they need. But as you say, there's many customers not really understanding what they need. They basically come up with their problem, with their application, and they don't really need how to solve that. And this is part of what we do and what we are proud of, that we are really looking into the application, coming up with proposals on how to solve the problem. Because in the end, you need the engineers to really help understand the problem, help understand the application, and then come up with potential specification sheet for a product.
Yeah.
But it's really not all the customers knowing what they need. In the end, it's about the engineers, it's about the companies with the expertise, helping understand what can solve your application. Okay. And this is what we really do with our engineering team.
As they say, people don't know what they don't know. And I say if you've got a difficult application and you put your standard lens on the front and it doesn't quite work, talk to the experts, because one, it might be the right lens. I've seen customers put a standard low resolution lens, they've gone to their 5 megapixel camera, still put the lens in, and they're getting a blurred image. Well, because they haven't got the MTF. So talk to the experts, engage with them, and it's really good to see that Schneider can offer that customization. Thank you.
Thank you.
Great, cheers.